Consider I'm your customer
Sure.
and you have 30 seconds. How will you sell your IPM device to me? Good,
Assemble.
good,
Assemble.
good.
It's assemble.
So first and foremost, this is the device itself. That is the GaN IPM.
Hello guys, welcome back to Foolish Engineers videos. I'm here today at PCIM Nuremberg 2024 and I'm going to showcase TI's booth, which is Texas Instruments, and they are going to showcase their new product. So we are going to see what I'm going to experience on their booth. Let's start. This video is made possible because of Texas Instruments. They are pioneers of semiconductor world. So now we are going to see the next demo from TI again. And here we have Zoom with us. Can you please introduce more about yourself?
Sure. No,
Yeah.
nice meeting you. My name is Zoom Dang, and I'm the product line manager for the brushless DC motor drive or BLDC at Texas Instruments.
Okay.
And here I'm very excited to announce TI's industry's first GaN IPM. So
Okay.
first and foremost, GaN IPM. IPM is Intelligent Power Module, which is a integrated power module that goes into a lot of HVAC system or appliance system today, like refrigerator, cooktop, washer, dryer.
Okay.
However, right, as the designers today are really getting to the ceiling of performance and energy efficiency for IPM, which is around 97%,
Oh,
with
okay.
IGBT as well as MOSFET today. So TI, we see an opportunity to help the engineers break that barrier and getting to that 99% efficiency with GaN. So we've been able to introduce and integrate GaN into a three-phase BLDC GaN IPM system.
Okay.
And really excited to announce and show the demo today on that.
All right.
Yeah.
So can you show me what exactly is going inside this small development board which you have demo? And also, if you can you tell me how many GAN devices are inside?
Of course, of course. So first and foremost, this is the device itself. That is the GaN IPM. And to answer your simple question, we have been able to pack all of the GaN components as well as the driver in a single package. So the entire system is powered driven by just one device with GaN powered in here. Right, so there is a device today. So this is again IPM DRV7308.
Okay. And how many so if it is IPM, how many FETs are there? How many drivers are there? And what exactly it does inside?
Right, right. Great question. So typically in a IPM, there are typically three phases. So with the specific GaN IPM, we have three phases and
Okay.
total of 6 FETs. So 3 high side, 3 low side,
Okay.
all GaN driven. And typically this is used to drive a BLDC motor.
Okay.
And for this application, that is high voltage.
So
also
all of
650
those
volts.
6 FETs are in this small package.
That's correct.
Oh, that's great.
Yeah.
And what is the voltage and RDS on of this FET?
Good question. So this is high voltage, running at up to 650 volt amps max.
Okay.
Typically, we can support system that runs at 450 volt continuous. And the RDS on is roughly 205 milliohms.
Okay.
So if you translate that into power, that means that this GaN IPM can support up to 250 watts operation without the use of a heatsink.
All right. Oh, thank you so much.
Yeah, absolutely. So if you take a look over here, this is how we have been able to design this GaN IPM into a system. So this is a motor inverter board that supports up to 250 watts. So if you can look at, this is a QFN package, 12 by 12, and we've been able to shrink that into this size, right? Compared to traditional IGBT or MOSFET, what that typically comes into leaded packages, which is up to 55% bigger from the board size standpoint, as well as component size.
The whole system, how it works and how is exactly power flowing from input to output.
Of course. So what we have here is the power supply, and this is the oscilloscope is showing the slew rate, right, or the switching current. Ultimately, if you look down here, the system is running at 300 volts, and that is the current that is drawing roughly 200 milliamps. As you see, this is the power stage with the board. As mentioned before, there is a camera that is really measuring the low thermal or dissipation from a power standpoint achieved by GaN IPM. Ultimately, the system is used to drive a fan load on the right hand side. So the system is running at roughly consuming 50 watts, as mentioned before, and that's really ultimately meaning maintaining extremely low current as well as low power dissipation enabled GaN IPM.
Okay. Can you explain about the application? In what applications these are used?
Right, right. So typically, GaN IPM is going into a lot of applications like appliances and HVAC system. Some of the customers that we talk to are doing designing in refrigerator, compressor. You're thinking about the air handler within the HVAC system. You're talking about cooktops, washer dryers, right?
Okay.
So all of those small appliances, pumps and fans. Now, ultimately, what our end customers are looking for is, can you increase the energy efficiency? As energy and efficiency center
Okay,
goes up.
let me stop right
Yeah.
there. Uh, Consider I'm your customer
Sure.
and you have 30 seconds. How will you sell your IPM device to me?
Great question. Really,
We'll start the, yeah, now.
all right, sounds good. So if you want to achieve 99% efficiency, if you want to remove the heatsink of the out of the system, if you want to reduce your board side in the system solution by more than 55%, and ultimately if you want a quieter and lower and better acoustic system, you need to move to GaN IPM.
How much do I have to pay for that extra?
We are competitive at the system level. I think ultimately you gain from cost, but also from performance with GaN IPM.
Okay, okay. So do you have any percentage comparison for that?
Yes, we for all of the comparison, performance, stack, as well as commercial. We have all the information listed on the website.
Okay. Well, thank you so much for this amazing demo. It was nice to meet you.
Thank you so much.
Now we are going to see the next demo. We have,
Hi, my name is Sabarikanan. I am a systems engineer at Texas Instruments. I work in the robotics team.
all right. So now what we will do is, I have a fun game with us, and I will basically show you different symbols, electronic symbols,
Okay.
and you have to just identify those and tell me whether it is symbol or not.
Okay.
It will be a rapid fire.
All right.
Okay. Are
Yeah.
you ready?
Yeah, I'm ready.
Okay. So yeah.
Symbol.
Right.
A symbol. It's a symbol. It's a symbol.
Right.
It's a symbol.
Right.
A symbol.
Right.
Not a symbol.
Right.
Not a symbol.
Yes. Right.
Symbol. Not a symbol.
Okay.
A symbol.
Good.
A symbol.
Good.
A symbol.
Good.
It's a symbol.
Thank you.
Thank you too.
What can you show me about this new part?
So here we have the demo for the three-phase GaN inverter, and this is specifically for the industrial robots, so cobots. And this reference design has three GaN chips, so it's LMG2100. So this three GaN chips handles a three-phase of a single BLDC motor.
And how much power it can handle in this design?
So we have around 700 watt.
Okay.
Yeah.
All right. And can you explain me about the schematic behind this, or just block diagram behind this particular demo board?
Yeah, sure. I have a block diagram here. So here you see this dotted box. That's a single GaN chip that we have. So it has an integrated GaN driver with GaN FETs, 100-volt GaN FETs. So we have three of these, and there are shunt resistors to measure the current through each phase. So the current is measured by this INE 241 chips.
Understood.
Yeah.
And we have the input of how much? 12 volts to 6.
Yeah, currently
60
I have
volts.
a 24-volt input for this motor, but
Okay.
it can handle in this range.
Okay. And how this motor is being controlled?
The motor is being controlled by this C2000 microcontroller
Okay.
that generates the pulses that's required for the GaN driver to control the effects.
All
GaN
right.
effects.
And it can just give 5 volts output for this GaN fits, and it takes care of all the driving and everything inside.
Exactly, you are right.
Okay. Now, can you show me a bit about this demo board which you have? How many GaN ICs are there, and where exactly are they located?
Okay, sure. You could see the three black chips, right? So those
Okay.
are the GaN drivers.
All right.
With
And
the integrated effects, yeah. As you
okay.
can see here are the terminals for the motors.
Okay.
That goes directly to the
All
servo
right.
motor.
Well, that's a wrap. I hope you picked up something useful from this video. The reference of this design is added in the description below. While checking the reference, please don't forget to hit that subscribe button as well. It's right over there. I'll see you next time. Till then, stay hungry, stay foolish,